Hello guys, namaste everybody, welcome to Game Factory. This video is about how we can create target lock-on system in Unity. At the end of this video, our character will be able to lock an enemy and strafe around it, like you see in Dark Souls. This is a quite advanced topic to cover, but I've tried to make it simple as possible, so I recommend not to skip any part. Before starting the video, thanks to all those new subscribers. We've grown from 100 to 150 and it's good to have you guys to support this channel. If you are new or haven't subscribed yet, then please be sure to hit the subscribe button right now because I will be making videos on advanced and new topics that may not be covered in the internet. So keeping that aside, let me give you the table of contents of what we are going to do. First of all, we are going to create a new camera that we can switch and lock onto target object. Second, we are going to create a script that is going to select a nearby target. Third, we are going to create an user interface or an indicator that follows our target. Then we will download movement animation and create a strafing system. Within this, we are also going to learn why some animations that we download from Mixamo are not working properly and how to solve it. And at last, we are going to finalize everything. So without wasting any more time, let's start the work. To make you comfortable with what is going on here in this scene, we have a player character in the scene. It can do a simple movement. Here is the script for the movement. I'm also controlling the camera rotation according to the mouse axis and with the help of an empty game object. And here is how it works. And here's the script. Why I'm showing you this is because later while programming our locking system, we are going to make few simple modifications in our movement and camera system. It depends upon what you have and what you are actually doing with your game. So yeah, so except that we have some environment objects and couple of enemies of different sizes, and that's all to start making our locking system. Let's get started. The first thing we are going to do is to set up a camera. I'm using Cinemachine for camera works. Click on Cinemachine and then add a visual camera to the scene. After that, I created an empty game object called enemy target locator and assigned it to look at override. Now you can see for the follow override, I attached the camera target object because it follows the player. You can also attach your player character if you do not have anything that follows the player. Set the body to framing transposer and aim to composer. You can take a look at my settings, but you should be playing around with these numbers and sliders to get the best for your game. Now that we have two cameras, we need to make them able to switch between one another. For that, we are going to use Cinemachine state-driven camera. If you currently have something to switch between two cameras, then you can use your own system, but in our case, we are going to make a new one. So let's add a state-driven camera and keep both cameras as its child. We are going to use animator controller method to switch between camera. Just add an animator component and create a new animator controller. And inside that controller, we are going to create two empty state and name them accordingly. What happens is if follow camera animation is being played, then our default follow camera will be enabled. And if target camera animation is being played, then our target locking camera is going to be enabled. You can add as many cameras as you want and control them via this animator controller. But it's not finished yet. We need to make a script that follows the animation. Let's begin coding this stuff. Create a new script and name it whatever you want. Now you don't have to copy the code because I will be providing the code in the description below. But the thing I am going to show you here is about the logic behind what's being used to achieve a lock-on system. We're going to use Physics.OverlapSphere to grab nearby enemies. This is a function. With this function, we can get area of colliders that are within a specific range. After we have all nearby enemies, we are going to calculate angle for each of them to select the object with shortest angle. Following that, we are going to get the chest area of target to view some sort of indicator. For that, we are going to calculate its height by multiplying the height of collider with the y coordinate of its scale and divide it twice. And again take that value and subtract it with the total height. Next, we are going to throw a ray to check if any object is blocking us from our target, and also knocking off the target if we are too far from it. It's time to create the indicator. Let's create a canvas and add an image UI into the scene. You have to set the render mode to world space, attach the camera and adjust the size. Finally, give your design to the UI image. First of all, we need to solve the problem of it looking at the camera. To achieve that, I created a script that makes an object look at camera and behave as a billboard. This is the script that does that job for us. It's quite a simple program. When our object is enabled in the scene, we are going to call an enumerator that makes our object to look at a given target. The script is provided in the description box. And for the second problem, it's being hidden inside our enemy object or any other object that is being currently targeted. We are going to create a new camera that will only render the canvas. Create a new camera and attach it to the main camera. Change the setting as following. Change the clear flag to depth only, and this is the part where you want to make a new layer for your canvas. I named it second vision. You can name whatever you want. Set the layer of lock on canvas to second vision, and after setting of that, the UI element will be rendered in front of every other object. Now the last thing we are going to do with the UI thing is the scale. To make the scale constant in the screen, I made the UI element to scale and adjust in proportion to distance from player to enemy. While our target is locked, we want our character to move in a specific manner. That means we are going to make it strafe around our target. For that, we need some animations. I downloaded a couple of animations from Mixamo. You can also get them for free. Head towards mixamo.com and get your animations. But remember, you need to download these animations in correct manner, or else they are not going to perform well. One of the way to download is to download the character model first. Like I did download YBot, and while the same character is being selected, we are going to choose and download the animations. We are going to download total 5 animations. Jog forward, jog backward, jog strafe. It can be left or right. You can download any direction you want. Jog forward diagonal and jog backward diagonal. But keep in mind that the animation should be running in the same place. Check the in place option before downloading them. The reason we are not downloading strafe animation for both left and right direction is because we can mirror these animations in Unity and make them work for both directions. After importing animations, you have to change some settings. Select the character FBX file and go to Rig tab. Change the animation type to humanoid and avatar definition to create from this model. Do the same for all the animations, but instead of creating their own avatar, we are going to use the avatar of the character model. Go to Animation tab and rename your animations, and finally copy this config for all those 5 animations. And let me tell you, if you're using your own animations, then you have to change the settings according to the type of animations that you are using. We are done with all animation, and it's time to set up our animated controller. First of all, add 2 new float parameters as vertical and horizontal. Second, go to Layer tab and add a new layer. Name it Strafe Movement. Inside that layer, add a new blend tree. Change the blend type to 2D freeform directional and set parameters to horizontal and vertical. After doing that, you can add motion to the blend tree. Motion meaning your animations. And if you are new to Animator, then you may get confused here. The first thing you need to add is an idle animation and set its X and Y position to 0. Now you need to add your strafe animations and plot them like you do in graph according to their direction. For example, if you have animation moving towards right, then the position X is going to be 1. If your animation is moving towards left direction, then the position X is going to be -1. The same thing goes for forward and backward. If your character is moving forward, then your position Y is going to be 1. And if your character is moving backward, then the position Y is going to be -1. Let's say if you want to go diagonal, upper left, then the position X is going to be -1 since it is moving towards the left direction, and the position Y is going to be 1. So add all of your 8 animations for 8 different directions with an idle animation into the blend tree. And the other thing to mention is, if you download animation, let's say only left direction is stripped, then you can check this box to mirror it towards the right direction. And if you have got some actions in your game like attack, dodge or some other activities, then you can program your code to set the layer weight to 0 and bring it back to 1 after performing the action. Go to your movement script and change the value of those vertical and horizontal parameters in proportion to the input. Now I'm going to solve this little problem with my camera. After locking onto a target, when I tried to switch to default camera, it was changing its direction. I mean, it's supposed to look at the same target and wait for our input to rotate, but it was adjusting and rotating off direction without any input. To fix this, I made the camera follow object to copy the rotation of main camera when we are locking onto a target. By doing this, the first camera stays exactly the same position and rotation of its second or current camera. Finally, everything is done and here is the result. There you go, now you have an enemy target locking system in your game. You may improve the gameplay by adding different movement types or different actions like walk, run, dodge, dash, etc. I try to make this video as simple as possible so that it becomes easier to understand the concept and achieve a good target system. Before leaving, if you like the video, then please be sure to subscribe this channel and hit the bell icon to be notified for upcoming video. Thank you for watching. Until next time, goodbye and take care.